Bismillahirrahmanirrahim. For today, we are going to speak about the relative maximum and relative minimum of a function. Let's start with the definition. What do we mean by relative maximum or relative minimum? Because we have two types of extrema for the function. One of them is called the absolute maximum or absolute minimum. That will be the highest value among all the domain of the function, or the lowest value of the function through the whole domain of the function. We call this the absolute maximum or absolute minimum. In some other cases, we are looking for the relative, just in a small period or portion of the domain. We will look for the highest value of the function, just in a small area or in a small domain of the function, or the lowest value. These two values, they are called the relative maximum or relative minimum. For example, if we are looking for this point here between these just in a small interval, we can see this one is the lowest value between the, let me call it x1 and x2. In this domain, it is the lowest value. So this one we call a relative minimum. Means it is the lowest just in a small area or in a small interval. It is not the lowest of the function in the domain. But we are just taking small period and looking for the smallest value or the highest value. For example, if we speak about this one, it means take in this interval. We call this is x3 and x4. This one, this value is the highest in that interval. So this will be called the relative maximum. So relative maximum or relative minimum, it is just the value stated comparing to the neighborhood of that point in a small neighborhood. So we have relative maximum or relative minimum, and also we have absolute maximum and absolute minimum. Absolute maximum is the highest value of the function over the domain, the whole domain of the function, but relative maximum is the highest among the small period or interval. To write the formal definition for this one, say that a function f said to have a relative maximum at x sub 0 if there is an open interval containing x sub 0 on which f x sub 0 will be the largest value. Such i.e. f of x sub 0 greater than or equal to f of x for any x contained in that interval. Or all x in the interval. Same thing for the minimum. So if it's said to have a relative maximum, if this condition is satisfied for any open interval containing x sub 0. If we just reverse the sign of the inequality, if it is less than or equal, then we will have a relative minimum. Let's state some theorem. Suppose that f is a function defined on an open interval containing the point x0. F has a relative extrema at x equal to x sub 0, then x equal to x sub 0 is a critical point. Critical point. It means that the relative maximum or relative minimum just happen to be in the critical point of the function. And the critical point of f, either that the derivative at x sub 0 equal to 0, or f is not differentiable. X sub 0. So we have for the critical point, we said that the critical point, it is the points, or these are the points where the function has a relative maximum or relative minimum. And the critical points are defined to be when the derivative of the function is equal to 0 at this point, or if the function is not differentiable. In other words, sometimes we say that the derivative of the function is not defined. If we go back to the graph of the function, let's see. This is relative maximum. If we graph the tangent line at that point, we will see we have a horizontal line. Horizontal line is the derivative equal to 0, because we know the slope of the tangent line equal to the derivative. So when we have a critical point means that we have a tangent line or horizontal tangent line with slope equal to 0. And that's the meaning of f prime of x sub 0 equal to 0. So the critical point means that we are going to have a tangent line with a slope equal to 0 or a horizontal tangent line. Or the other type, if the function is not differentiable at that point. Not differentiable either, we will have corner in some part of the function. Not differentiable means that the limit of the definition of the derivative is not exist. It happens when we have a corner. For example, in the absolute value function, the vertex of the figure will be relative minimum or relative maximum depending on the sign is positive or negative. But at that point, in the vertex, the function is not differentiable because you have corner. Now, the critical point x or stationary point f prime at x equal to 0. If it is not differentiable, we say the function is non-stationary point. So the critical point is called stationary point if the derivative equal to 0, but if the function is not differentiable, we call it non-stationary point. Now let's explain how to find the critical point for some function. So we are going to find the critical point in this part. Find the critical point. Example, find the critical point number 1 equal to say x to the power 5 minus 5x to the power 4 plus 5x to the power 3 minus 15. And we need to find the critical point of this one. Now to find the critical point, let's just differentiate. F prime of x is equal to 5x to the power 4 minus 20x to the power 3 plus 15x squared. And to find the critical point, just make this equal to 0 and solve the equation for x. Now solve for x. I will take 5x squared as a common factor. Then I will have x squared minus 4x plus 3 equal to 0. By factoring, this is equal to 5x squared multiplied by x minus 3 and x minus 1 equal to 0, which means x equal to 0 or x equal to 3 or x equal to 1. So these are the critical points. Critical points are 0, 1, and 3. So these are the critical points of this function. The idea is differentiate and equate it to 0, then solve for x to find the critical point. Another one, example number 2. F of x equal to x minus 2 to power 2 multiplied by x plus 1. So let's find the derivative. The derivative of this function, we apply the product rule. This is by, or let's say apply the product rule. That will give me f prime g plus g prime f. So f prime is 2 multiplied by x minus 2 multiplied by 2x plus 1 plus. This is f prime. This is g. Now derivative of g, the second one is 2 multiplied by x minus 2 squared. On the critical, we make this equal to 0 and solve for x. I will take 2x minus 2 as a common factor. 2 multiplied by x minus 2 as a common factor, I will have the first part, it is 2x plus 1 plus the second term will give me x minus 2 equal to 0. We took 2 multiplied by x minus 2 as a common factor. From the first one, I will have 2x plus 1. From the second one, I will have another x minus 2. So this is equal to 2 multiplied by x minus 2 multiplied by 2x plus x is 3x minus 1 equal to 0. So either x equal to 2 or x will be 1 over 3 from the second bracket. So the critical point, CB means the critical points are 2 and 1 over 3. So the critical point for this function are 2 and 1 over 3. Take one more. Number 3. F of x equal to 1 plus 8x minus 3x squared. And we need to find the critical point. So let's differentiate. F prime of x equal to 8 minus 6x. Now to find the critical points, make this equal to 0 and solve for x. We'll have x equal to 8 over 6, or it is 4 over 3. So this is the critical point. So the critical point for this one is 4 over 3. One last example. Number 4. Have f of x equal to 3 multiplied by x to power 5 over 3 minus 15 x to power 2 over 3. Let's differentiate this one. Prime of x equal to 3 multiplied by 5 over 3 multiplied by x to power, if we just deduct 1, it will be 2 over 3. So it's 5 multiplied by 5 over 3 times x to the power 2 over 3 minus 10 multiplied by 2 over 3 x to the power minus 1 over 3, which can be written as 5, got this 3 will cancel this one, and I will have 5 there. That is 5 x to the power 2 over 3 minus 10 x to the power minus 1/3. We can write it as 1 over third root of x. Now, this is the derivative. F prime of x. 5 x to the power 2 over 3 minus 10 times 1 over third root of x. This can't be equal to 0 unless x equal to 0. But when x equal to 0, the second term is undefined. Second term is undefined. So this can't be equal to 0. But it is not defined when x equal to 0. It's very clear that f prime of 0 is undefined. So we can say the function f of x is not differentiable. At x equal to 0. Which means, it means x equal to 0 is a critical point. It means when x equal to 0, we will have critical point at this value. So this is the critical point, x equal to 0, because the function is not differentiable at x equal to 0. So we can think about this one. Now, let's go back to that. Our definition, the critical points are the point where the derivative equal to 0 or when the function is not differentiable. And this is example for a function which is not differentiable at x equal to 0. So x equal to 0 is a critical point. Number 4. Have f of x equal to x squared divided by x squared plus 1. Let's try to find the critical point for this function. Now, by the quotient rule, the derivative of this function is equal to the denominator square quotient rule. Is f prime g minus b prime f over g squared. Now f prime is 2x multiplied by x squared plus 1 minus derivative of the denominator, which is 2x multiplied by x squared. Simplify it. I will have 2x to the power 3 plus 2x minus 2x to the power 3 divided by x squared plus 1 to the power 2. The derivative now is equal to 2x divided by x squared plus 1. And to make it equal to 0, we'll have the only value for x that makes this correct is x equal to 0. Can be done by cross multiplication also. So x equal to 0, which means this is by cross multiplication. I will have x equal to 0. So the critical point is x equal to 0. For this function, we have only one critical point that x equal to 0. So this is how to find the critical point for a given function. In the coming part, we are going to discuss the type of the relative maximum. Is it relative maximum or relative minimum? We have to test these critical points. Are these relative maximum or relative minimum? And for finding that, we will have two types of tests. We call the first one the first derivative test, and the second one is the second derivative test. That will be given in detail in the coming part.